Hello everyone. Now we will see the spring constant or the force constant of a springs connected in parallel combination. In the previous video we have seen the combination of the springs in the series. Now we will connect in the link of the previous video. I'll give in the description, you can check that. So now we have considered the S1 spring with a K1 spring constant, S2 spring with a K2 spring constant that has been connected in parallel combination. So when mass m is loaded to that, x is the extension which is taking place, this stretching which is taking place. So this is the initial position of that. When mass is added, this much stretching will take place. So what we have is S1 with the K1 spring constant. Here the x1 extension is taking place. S2 with the K2 spring constant. Here x2 is the extension which is taking place. Fine. Now for both the combination, that is the S1 and S2 connected in parallel, the Kp is the spring constant and x is the extension which is taking place. In this case, this x1 is equal to this x2 is equal to x. So here it is x1 is equal to x2 is equal to x. So we have to remember this. So this is the key step in this parallel combination. Now let us write according to the Hooke's law or the definition of the SHM. Restoring force is equal to minus k into x. For the spring S1, it will be F1 is equal to minus K1 x1. Here there are two forces acting on this spring. F1 is a force in the S1 spring, F2 is a force in the F2 spring. So here for S2 we have F2 is equal to K2 x2 with a minus sign. So let us find out here. Say this is equation number 1 and this is equation number 2. For parallel combination, that is, say F, the total force which is there, F is equal to it is minus kpx. Say this is equation number 3. So the total force is equal to force F is equal to, we can have to write this F1 plus F2. So let us substitute the value of F, that is minus kpx is equal to, the value of F1 is minus k1 x1 minus the value of F2 is k2 x2. Here this minus sign will get cancelled, and then we know that from the diagram x is equal to x1 is equal to x2. So we can write this equation as this kpx is equal to k1x plus k2x. So here this x and this x will get cancelled. We remained with the kp which we wanted in this equation. Kp is equal to k1 plus k2 for 2 springs. For 3 springs it is k1 plus k2 plus k3. For n springs we have kp is equal to k1 plus k2 plus k3 plus till kn. So we can write this in the form of summation ki, that is I is running from 1 to n. So this is the spring constant of a springs in parallel combination.